Google's Willow chip is touted as not just another technology breakthrough, but an evolution in the way we solve some of the world's toughest challenges.
Right now, in a cold room in California, there's a chip smaller than a coin, sitting in a box colder than deep space. A year ago, it did something that, by the rules of our universe, should have been impossible. When the man who built it tried to explain how, he didn't reach for better engineering. He reached for other universes. He said, in public, that the answer had to come from realities we can't see. That's not a mystic talking, that's the head of Google's quantum lab. Follow that one sentence far enough, and you walk straight into the oldest question a human has ever asked. Where did all of this come from, and did anything build it? This isn't ChatGPT. It's a completely different kind of machine, one that doesn't think in words at all, and what it pushed its own creators to say has split serious scientists straight down the middle. Some call it the best hint we've ever had, that reality is far bigger than we were told. Others call it a brilliant machine wrapped in a wild story. Either way, it should have been the biggest science news of the year, and almost nobody heard it. Stay with me, because the strangest part isn't the machine. It's that we may have just built the first tool that can walk up to the question of where the universe came from and knock on the door, and every answer it leaves standing makes you smaller. Before we go any deeper, if you are the kind of person who looks up and wonders what's really out there, a gentle like and a tap on subscribe would mean more to me than you know. It's the only way this small channel keeps looking up with you, because this only gets stranger the deeper we go. The machine is called Willow, and Google unveiled it at the end of 2024. Here's all you need to know about how it works. A normal computer solves a hard problem one step at a time, in a line. This one doesn't. It works through a staggering number of possibilities all at once, and Willow has 105 tiny engines doing it together. That's the whole physics lesson. Everything strange in this story grows out of that one fact. Then they ran the test that went around the world. They handed Willow a single problem, and it finished in under 5 minutes. Then they worked out how long the fastest supercomputer on Earth would need for the very same job. 10 septillion years. A 1, with 25 zeros behind it. That's not 1,000 times longer than the universe has existed, not 1,000,000. It's longer than the universe is even expected to last. Past the death of the last star, out into the cold and the dark at the end of everything. Try it another way. If every single atom in your body were its own supercomputer, and all of them had been running this one problem since the day you were born, they still would not have scratched the surface. Willow closed it in the time it takes to pour a cup of coffee. So forget the speed for a second. It's the size of that gap that matters. A gap that wide isn't just a faster machine. It's a machine doing something our whole idea of a machine has no room for. When a result won't fit the model, somebody has to go and find a bigger model. That's exactly what the man who built it did. His name is Hartmut Neven, and he runs Google's quantum lab. He is not some outsider. He's at the dead center of this field, one of the most respected people alive in it. The explanation he reached for wasn't about circuits or engineering. He said the number was so far past anything physics even has a clock for that it points to an old, unsettling idea. That the machine had, in his own words, borrowed the computation from parallel universes, that we live in a multiverse. The man who built the fastest thing our species has ever made looked at what it did, and told the world the only way he could explain it is this. Reality is bigger than one single world, and his machine reached into the others to get the work done. He didn't invent that idea. It goes back decades, to physicists like Hugh Everett and David Deutsch, one of the founding minds of quantum computing itself. What it says might be the strangest sentence in all of science. Every time a tiny quantum event could go two ways, it doesn't choose one, it goes both. The world quietly splits in two, and both of them are real, and both of them keep going, forever, never seeing each other again. It isn't some rare cosmic event. It happens with every particle, every collision, every flicker of every atom, everywhere, all the time. As you sit here, reality is splitting into uncountable copies of itself, an endless tree of worlds branching off from this one, every single second. On that picture, a quantum computer isn't magic. It's fast for one simple reason. It isn't working alone. It spreads the problem out across all those branching worlds and lets them solve it together, more hands on the job than exist in this world by itself. That is what Nevin says Willow was really doing, not calculating harder, reaching sideways into the others. This is the part David Deutsch worked out decades ago, long before there was a machine to point at. He argued that a single quantum computer could never hold enough raw material inside one world to do what it does, that the numbers simply don't fit inside the atoms we can see. Something has to be doing the extra work, somewhere we can't look. For years, other physicists treated that as a way of speaking, a colorful picture laid over the equations. Nevin's discomfort is that Willow makes the picture hard to wave away. The machine really did finish a task too big for this world, so either the math is lying, or the other rooms are real, and something in them is helping. And if he's right, those other worlds are not empty. Some of them hold a version of you. One that's watching this same thing, at this same hour. One that switched it off a minute ago. One that made a different choice 10 years back and is living the life you didn't take. One where you were never born at all. All of them just as real as the room you're sitting in. All of them running, right now, right next to the world you always thought was the only one you had. And here's the part that's hard to shake once you've heard it. In that picture, you are not really a single person living one life. You are a whole spray of people, splitting apart a little more with every passing second, each one convinced they're the only one, each one just as sure as you are right now that this world is solid and singular and theirs. The machine on that bench isn't proof that any of this is true, but it's the first physical thing that made the men who understand it best stop and take the idea seriously and get quiet. Not everyone buys it, and the ones who don't aren't fools. Plenty of serious physicists think Nevin reached too far, that the same strange math works perfectly well without any second universe, that the multiverse is just one story you can lay over the top of it. They might be right. Nobody can prove who is. But the argument doesn't stop there, because underneath it runs a second thread, and it's stranger than the first. Follow the physics down, past the chip, into the structure of space and time itself, and you start finding things that look less like an accident and more like a design. Start with the machine's own trick. Willow's real breakthrough was never raw speed, it was protection. The reason quantum computers spent 30 years going nowhere is that their information is almost unbearably fragile. A stray flicker of heat, a single vibration, and the answer collapses into noise. What Google finally cracked was a way to guard that information, to spread it so thin across the machine that even when pieces of it are destroyed, the message underneath survives untouched. Engineers have a name for it: error correction, building a system on purpose so that it cannot be broken. Now hold that idea and look at what physicists find when they study the deepest fabric of reality itself. In our best mathematical picture of space-time, the universe appears to be built the exact same way. The information inside a patch of space seems to be written out along its outer edges, protected, backed up, recoverable, precisely the way you would build a system whose one job was never to lose anything. Picture everything happening inside a room somehow written in full on the walls around it, so completely that you could wipe away half the wall and still rebuild the entire room, every detail from whatever was left. That is the shape of what they found in the mathematics of reality. Reality keeps its own backups. It stores itself in more than one place, so that no single piece of it can ever truly be erased. That is not how a random pile of matter behaves. That is how you design something you are afraid to lose. At its base, the universe looks less like a pile of rocks that happen to fall together, and more like a message someone wrote out carefully, with backups, so that it would never, ever be lost. Nobody sat down and made it that way, or nobody we know of. The math just came out looking like the work of something that cared whether the thing survived. And it goes one step further, into something genuinely disorienting. In that picture, the inside of a region of space isn't the fundamental thing at all. The edges are. The three-dimensional world you feel around you, the depth, the distance, the room you could walk across, appears to be something reconstructed from information stored somewhere flatter and more basic, the way a solid-looking scene is rebuilt from flat data on a screen. If that's right, then the solidity of everything, the very sense that the world is really there in front of you, is the output of a process, not the bottom of reality. It's the picture on the screen, not the code underneath. Then there are the settings. The universe runs on a small handful of numbers, the strength of its forces, the weight of its particles, the energy humming inside empty space, and every one of them is balanced on the edge of a knife. Take the energy of empty space. It's tuned to a precision of about 1 part in a number with 120 zeros after it. That's a single dial, set correctly to more decimal places than there are atoms in your entire body. Move it, just a hair, in either direction, and atoms never form, stars never burn, and nothing and nobody is ever here to wonder about any of it. And it isn't just that one dial. Turn up the force that binds atomic nuclei by a few %, and the simplest fuel of the stars burns away in an instant, and no long-lived sun ever forms. Turn it down, and complex atoms never hold together at all. Weaken gravity, and nothing ever clumps into stars and worlds. Strengthen it, and the whole universe collapses back on itself before life could ever get started. Every one of those numbers sits in the one impossibly narrow band where a universe is able to make anything at all. Physicists have a dry little nickname for it, the Goldilocks problem. Everything, somehow, tuned to just right. Now put those two things side by side. A machine whose own maker says it computes across worlds, and a universe whose deepest structure reads like protected code, running on numbers that look deliberately chosen. You can feel the question changing shape under your feet. It stops sounding like religion, and it starts sounding like engineering. For thousands of years, the question of where the universe came from belonged to priests and philosophers, because there was no other way to touch it. You could believe an answer, or argue about one, but you could never measure it. What changed, quietly, in that freezing box in California, is that the question grew a physical edge. Something you can build a machine to press against. Because who writes protected code? Who backs information up so it cannot be lost? Who sits and tunes a set of dials to 120 decimal places so that the machine will run? That's the exact door a philosopher named Nick Bostrom opened back in 2003, and it's the one that is hardest to shut. His argument was cold, and it was simple. One of 3 things has to be true. Either every civilization wipes itself out before it ever gets powerful enough to build convincing simulations of reality, or it reaches that power, and then every single one of them, without exception, decides never to switch such a thing on. Or, the third door, the one nobody can quite close, we are almost certainly living inside one right now. Because if those simulations ever do get built, and get run, then the simulated minds end up vastly outnumbering the real ones, and a mind picked at random, your mind, is far more likely to be one of the copies than one of the originals. Elon Musk puts the odds that we are not in a simulation at billions to 1. More than one serious physicist now argues that reality, at its very deepest level, isn't described by mathematics. It is mathematics, not made of particles, made of structure, made of code, quietly running. And if that is what we are, then a strange new question opens under the first one. Not just who wrote it, but why. Why build a universe and set the dials so carefully that stars can burn, and chemistry can happen, and matter can fold itself into things that wake up and start asking who made them? Nobody has an answer to that. But notice what it does to the ground you're standing on. If the whole thing is a program, then the rules can hold perfectly for 1 billion years and still be changed in an instant by whoever is running it, and you would never feel the edit. You'd just carry on, certain the world was solid, the way you're certain right now. No machine proved any of this. Nobody got handed a receipt from a creator. And that is the part that's worse than a clean answer would have been. For the first time, we built a tool that can walk right up to the oldest question we have, and instead of one answer, it handed back 3. And every single one of them makes you smaller. If Nevin is right, you're one of countless copies of yourself, scattered across worlds you will never reach. If the doubters are right, this one world still runs on math that reads like written code, tuned by something nobody can name. If Bostrom is right, the floor under your feet is a program, and you are a line inside it. Pick whichever door you can live with. Not one of them leaves you the size you were when this started. The chip is still sitting there tonight, in the cold and the dark, ready to answer again. The people who built it are staring at the same result, and they cannot agree whether they have caught a glimpse of other worlds, the source code of this one, or nothing at all but a very fast machine and a very old human hope. It isn't going to explain itself. Whether the universe has a maker, the machine can't tell you. It only made the question real. The rest, it turns out, still belongs to you.